Red means to put in order. It's what we do at Red Remedies. Put your body in order as it relates to health. Please enjoy this webinar from our Master Herbalist, Stacey Littlefield. We hope this gives you greater insight into the very complex, very interesting world of essential oils and how they can affect your health.
So let's get started. We're going to talk about chemistry today. I'm so excited. We're also going to talk about some toxicology. I think the toxicology of essential oils is something that should be discussed more, not only with retailers but also with your customers, and we'll go through that. But this is just an introduction to chemical composition and an introduction to some toxicology with essential oils, plant fractions. So this fraction of the plant contains the volatile principles of the plant that give it its aroma or fragrance. But not every plant creates essential oils. There's about 17,000, somewhere between 17 and 18,000 plants that actually create essential oils. They're usually liquid. There are a couple that are solid at room temperature, and the majority are clear and colorless to a very pale yellow. Now, there's always exceptions to the standard, and a couple of those notable exceptions are German chamomile, which is this pretty white flower right here. The essential oil fraction of German chamomile is a nice cobalt blue color, and that's because of the azulene content of that oil. And valerian, which is right here, very pretty purple flower. Smells, the root smells really bad, but that one is a bright, it's bright green. So there's just a couple exceptions there. So in nature, you know, plants make essential oils for a reason. I'm sorry, I'm on two screens here. So plants make essential oils for a reason, and they are really important to the plant, particularly in defense. So if a plant is attacked by a microorganism, like we have down here, this is blight on a potato plant, or they're attacked by insects like caterpillars, they will release these essential oils in response to try to kill the microorganisms down here, or to try to make their leaves taste of not so good to the caterpillar, or to make the insects sick. So the roles that essential oils play in defense, we know that they also do that for humans. We know that essential oils have antifungal properties and antimicrobial properties. We know that some of them are insecticidal. So that's the role that's one of the roles they play in nature. But they're also involved in the signaling process. The aroma that they put out into the air attracts pollinators. They also play a role in water regulation, how much water is delivered to different parts of the plants, and so they're not just there to smell pretty. They have really important roles in the plant, and they are found, essential oils are found in all different plant parts. You find them in the flower, you find them in the roots, you find them in the bark, so they're in all different parts of the plant. So when you look at the occurrence of essential oils, you know, across different species, you'll see that the percentage of total essential oil will vary among different species. You have, you know, as low as 0.5% in Melissa, so this lemon balm is Melissa, all the way up to 7% in caraway. And there's going to be a range for most of these because, you know, it's so many different factors will play a role in how much essential oil is available in a particular plant, and we'll go over those in a second. But you'll see a range. So not very big percentages. Essential oils are not the main component of most plants. So like eucalyptus, you'll 1 to 3%. So you can imagine how much total tons of eucalyptus it takes to make, you know, 10 pounds of oil or something. It takes a lot of plant to make essential oil. So let's talk about the variability of essential oils. Now, just like with botanicals or an herbal extract, the essential oil fractions will vary within a species. And let's let's just remember for a second what essential oils do in the plant. They're there for defense. They're there for signaling. So their environment is really important when it comes to what essential oils they're going to make, the composition of those oils, and the amount. So precipitation, wind exposure, exposure to pathogens, temperature, all of those things are going to play a role in the essential oil content. The growing conditions also play a role. The quality of the soil. If the quality of the soil is poor, then the overall composition of the plant is also going to be poor, to include the essential oils. Harvesting techniques play a role. The essential oils are volatile and reactive, so if it's better for things like lavender I show here to be hand harvested rather than by a machine, because the machine is a little more traumatizing to the plant than hand harvesting is. And then also the developmental cycle of the plant. That's also really important. You know, flowers at full bloom are going to have very different essential oil content than flowers that are just budding. So plant development plays a really big role, huge part in the variability of the essential oil fraction. So when we talk about variability, we're also talking about chemotypes. Now, a chemotype is basically essential oils from the same type of plant, but with different major components. Thyme is a really good example of a single species with multiple chemotypes. So you have, you know, Thymus carvacrol, you have Thymus gosh, I have so much trouble with these, geraniol, and then you have the linalool, or, my gosh, yeah, that one, sorry, the terpineol, fuginol, thymol. So you have all these different chemotypes, and do any of the bottles of essential oils tell you what chemotype you take? I mean, do you know what chemotype you use? Most of the time, they're not going to be marked. So how do you know? And why are you using the oil? Maybe you want it to have a lot of carvacrol. Maybe you want it to have a lot of thymol. It depends on the purpose. So chemotypes are really, really important for aromatherapy, and also if you're using them topically, because all of these individual components of essential oils have very specific actions. So you don't just want one piece, you want them all, and sometimes you want higher, you know, thymol than you do terpineol. It just depends on what you want to use it for. So chemotypes are important. Chemotypes are usually tied to the country they're grown in. That is very true of rosemary. Rosemary cineole is going to come from the Mediterranean area, whereas rosemary camphor, you can find that more in Northern Europe, Central Europe, and also in the United States. But if you want rosemary cineole, it's coming from the Mediterranean. So let's talk about extraction. So essential oil extraction. There are, and I'm sorry, I'm on webcam, you're going to see me flipping through notes here. So there are two main ways that essential oils are extracted. You have distillation and you have expression. Expression is more commonly known as cold pressing. So in distillation, there's more than one way to distill a plant or any other compound. So you have three types of distillation. The most common is steam distillation. So you have the plants are put into the still, and then steam is injected at not high pressure, but low pressure and a little bit higher temperature. That's how most plant essential oils are extracted. But you also have water distillation. That's when the plant biomass is put directly into the water. So that's most often used with flowers because, particularly rose and orange blossom, those flowers are more fragile, and the steam distillation makes them kind of clump up together in blobs. So the steam doesn't penetrate the petals fully, so they use water distillation. You can also use a combination of water and steam, but in this case, the herb and leaf material isn't put into the water. It actually sits on a grate above the water, and then steam is injected from the outside. So those steam distillation, though, that's going to be the most common. And hydrosols, which some of you might be familiar with, or they're sometimes called floral waters, but hydrosols are byproducts of distillation. There is some essential oil in there, not very much, but you're going to have some of the other compounds that you're going to find in the plant material. Any of the water-soluble stuff, so things like polysaccharides and maybe a few polyphenolic compounds, not very many. Those are going to be in the hydrosols. So steam distillation, that's the most commonly used. Expression is specific to citrus essential oils. So it's basically a mechanical separation of the oil from the peels. So it's very specific to that type of essential oil. Now, back in the day, hundreds of years ago, this was done by hand, where they would basically like push on the peels with a sponge and then soak up the oils with a sponge and squeeze the sponge out and keep going from fruit to fruit. They don't really do that anymore. It's too time-consuming. So most modern expression uses a centrifuge. So it uses centrifugal force. So the rinds are kind of not really ground off. Grinding is not the right word. It's like punctured. The rinds are continuously punctured, and then the peels come off, the rinds come off, and then they just spin it really fast, and the essential oil just basically is filtered off into the holding tank. So it's not a complicated process. It still protects the integrity of the oil, but you can distill citrus oils, but it's not the most ideal way to do it. So, and I want to talk about solvent extraction for a second, because essential oils can also be solvent extraction. Now, this is not the most ideal because of the solvents involved. They use mostly hexane. Hexane, that's not, the prettiest thing that we want to be using. However, there are oils and plants where that is the absolute best option. And the best example of that is jasmine flower. Jasmine flowers are very, very delicate. You put those through steam and you destroy the flower. You will get nothing from it. So jasmine is sold as an absolute. It is not sold as an essential oil. So an absolute, if you see an essential oil labeled as an absolute, that's your cue that it was solvent extracted. So all absolutes are solvent extracted. Sometimes you see rosewood is solvent extracted. I've seen neroli absolute, although you can distill neroli oil. But jasmine you don't really see as an essential oil. So you're going to see that as an absolute. All right, so let's talk about essential oil composition. Now, we speak of essential oils as a singular thing, but they're not a singular, compound. They are highly, highly complex chemical mixtures. So a single essential oil will usually consist of over 100 very unique and specific individual compounds. So each chemical compound is related, but they have very distinct chemical structures. They are individual compounds or individual chemicals. So together they give the essential oil its aroma, its therapeutic properties, and at times its toxicity. So many essential oils will share the same compounds even though they are derived from different plant species, like thymol. Thymol is found in thyme, but you also find it in rosemary, and you also find a little bit in sage. So they're crossing species. It doesn't only come from thyme. So that's an important point when we look at adulteration. So sometimes to boost the particular percentage of one compound, they will spike an essential oil with oil from another species to bring up the thymol content if we want to stay on that. So a lot of constituents are found in only trace amounts, but there's usually one or two major compounds. So, and while we call essential oils oils, they are not fats, they're not lipids, they're just oily in nature. So they're not actually fats or oils in the chemical sense, like from a chemistry standpoint. So let's move on to the types of chemical compounds that you see in essential oils. So the bulk of essential oils are called terpenes. These are the compounds that are found in essential oils. And all terpenes are based on this guy right here called an isoprene. So you have a tail and you have a head. So monoterpenes are two of these hooked together tail to head. So they'll join right here. And you'll see elements of this. See that right there? Right in here. Whoops, I didn't mean to do that. In the canazoline. You'll see it right there. Sesquiterpenes are made of 3 of these units put together. So while monoterpenes are really, really common in essential oils, the sesquiterpenes are not. So canazoline is a monoterpene. You're going to find that in German chamomile, 10 carbons. Sesquiterpenes, not so much. So you don't really find, they're less common in essential oils. But this is the basic unit. So when we look at the chemistry of an essential oil, terpenes and this isoprene is the basic unit. They're all built off of this little guy right here. You will also find some alcohols. So bisbolol, you're going to see in German chamomile, citronellol from citronella, menthol and peppermint, that's right down here. So that's the chemical structure of menthol, and these are alcohol-based. You also have aldehydes. This is cinnamaldehyde, which is from cinnamon. This is what gives cinnamon its characteristic aroma, is this molecule right here. Citral is from lemongrass. You also find compounds called ketones, pulegone. That's a big one right now. Pulegone, you find high amounts in pennyroyal. But pulegone is present in most of the mint family. So peppermint, spearmint, you're going to find some trace amounts of pulegone. It's also thujone is also high in tansy. It's actually what makes tansy poisonous. So you also have some esters. So methyl salicylate, that is what is in wintergreen, and that's what makes wintergreen poisonous. So the thing about esters is that they're really intensely fruity, and this is when plant development becomes important, because the esters, so these compounds, are going to be highest when maturity has been reached in the fruit or the plant or full bloom of the flower. Now, I tried to put compounds up here that you may have seen before, okay? So like benzyl acetate. You see benzyl acetate a lot, like on a cosmetic label, and it looks like a really ugly word, but it's in cinnamon, it's in wintergreen, it is in lemongrass, it is in rosemary. It's a compound that plants make, and it's antimicrobial, which is why they put it in cosmetics, and it also has some aroma to it. So usually when you're looking for something to smell a little bit like almonds, you use benzyl acetate. So these, you also have phenols in here. So thymol and eugenol from clove. This is what thymol looks like. So we see thymol a lot in like Listerine. It's one of the chemicals in Listerine, antimicrobial. So, and ethers. So anatol and safrole are both ethers. They're both toxic. So the ethers you usually find in really small amounts. So those are just some examples. I'm going the wrong way. of some of the chemical compounds. So technical words, yes, I tried to pick things that you will see on labels, particularly with cosmetics. So, but all of these different compounds are based on this guy right here. So it all starts there. The isoprenes are really essential to plant chemistry. So let's talk about toxicology of essential oils. This is something that is a problem because it's not well communicated to the end user, to the consumer. There is a misunderstanding that all essential oils are very safe. That simply is not true, and there is toxicology involved. It is my personal opinion that people should not use essential oils internally unless they are working with a practitioner or they've gone to great lengths to make sure that their oils are what they say they are, that they know the chemotype of the oil, and it's been tested properly. Now, most consumers aren't going to do that, so unless you're working with a practitioner, don't take essential oils internally. I know there's a lot of information out there on the internet, and you can get lots of recipes and stuff, but I don't think it's the best practice, and we're going to talk about why that is. So remember that essential oils are highly, highly concentrated. They are more like drugs than any other plant fraction out there, okay, in terms of toxicity and toxicology. They're more like pharmaceuticals. So the toxic effects are correlated with the dose. Toxicology is always about the dose. The higher the dose, the more toxic something is. So there are known toxic effects of essential oils. Many of them are neurotoxins. Many of them are liver toxins. Many of them are skin irritants. We know that many of them are mucosal irritants, and actually we use them as chemical weapons. Mustard gas. Mustard gas is the essential oil of the mustard plant. So we know that they're mucosal irritants. Photosensitivity they cause in some individuals, and many of them are fetal toxins at certain doses. So pregnant women never, ever, 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 ever use essential oils internally. So let's talk about toxicology. Because essential oils are more concentrated, they are way more toxic than the source plant. So acute toxicity, children, elderly, and your pets are especially sensitive. So those are the three most vulnerable groups. Don't leave your essential oils laying out anywhere. So there are exceptions. Essential oils of pennyroyal and wintergreen are fatal in large doses. This is well documented. We know this. There have been many cases of poisoning. And just as an added aside, pulegone was just added to California's Prop 65 list as a known carcinogen. So, thujone, this is a fraction of essential oil. It is a neuroactive. It, in large doses, will cause convulsions. It happens to be insecticidal, but if you put this on your dog to kill fleas, you will also kill your dog. So don't do that. Present as a major constituent in wormwood, white cedar, tansy. It is what makes tansy poisonous, and sage, just common garden sage. Now, thujone is not water soluble, and it's not going to be present in infusions. So teas. So if you do a tea of, sage, don't worry, there's no thujone in there. But it is alcohol soluble. So if you do an alcohol extract of sage, there might be some in there, probably not enough to cause a problem unless you took the whole bottle, which hopefully no one's going to do. But it's in there, but not enough at the proper doses where it's going to cause a problem. So pinacanthone is another constituent that is a known toxin. So this is the major constituent of hyssop essential oil. It's neurotoxic, causes convulsions. Eugenol, that's the main ingredient in clove essential oil. It's also found in cinnamon leaves. So big doses of eugenol or clove oil will cause central nervous system depression, so trouble breathing, convulsions, liver damage. So let's go through some known cases of poisoning. Now, all of the cases of poisoning were the result of oral ingestion, not aromatherapy, not topical use, not diffusion, oral ingestion. Some of these were accidents. Most of them involved children, and a handful of them were done intentionally. So if there was a problem in the 90s with camphorated cottonseed oil, I don't remember people taking camphorated cottonseed oil, but apparently it was a problem. So in 2 of the documented cases, a pregnant woman accidentally ingested 60 grams. I don't know how or the circumstances, but she lost her full-term child. She was 9 months pregnant, lost her baby, and they found that camphor actually passes the placenta. It enters the lung of the fetus. It also enters the liver, it enters the brain, and it enters the kidney. It destroys the placenta and causes a hemorrhage. So that's what happens when you take very large doses of camphor. In a documented case in children, it causes delirium, convulsions, followed by central nervous system depression and coma. So that's why anything camphorated, so you know, like Icy Hot or Bengay or whatever, put that stuff away. Your white flour, you know, liniment, if they still sell that, I don't know if they still sell that, keep that in a place where kids are not going to get it. In one of the cases of camphorated cottonseed oil, the child ate it on a dare. So just put your essential oils away. Clove oil, I know that people will use that for toothaches. I suspect in the 7-month-old child this was purposeful, maybe was teething, I'm not sure. This baby did recover with medical intervention, and this 2-year-old also in intentional dose, not sure why, also recovered, but almost died. The interesting thing about this case right here is that his case closely resembled an overdose of Tylenol. So they believe eugenol acts in the same way that like acetaminophen poisoning would act. Eucalyptus is another one. There are a lot of documented cases of eucalyptus poisoning. So, you know, you're going to see a lot of the same kind of effects. So depressant, abnormal breathing, headache, weakness in the legs. So those are some of the cases of poisoning there. Now, let's talk about degradation, because essential oils are volatile fractures, so fractions of the plant. So the 3 major factors are oxygen, heat, and light. And the reason why those are a problem is that they all lead to oxidation of the essential oils. Now, the problem with oxidation is that those chemical changes in the molecules of the essential oils actually create more hazardous compounds. So it makes them more toxic. Terpene degradation will happen in essential oils. Terpenes are not very stable, and so they want to be, the free radicals see them as an easy target to steal electrons from. So terpenes will degrade very quickly, and especially with pine oils. So if you have an essential oil of pine, Scotch pine, whatever it is, and you've left it out in the sun or it's in a clear bottle, throw it away, because those lead to the formation of skin sensitizers that will cause rashes and other problems. Most essential oils should be used within a year of opening, and very volatile terpene-rich oils should be used within 6 months. So don't buy essential oils in clear bottles. Do not store your essential oils in clear bottles. Keep them away from sources of heat and light. So for the most volatile ones, the best place to keep them is in your refrigerator, but the problem with that is they get really thick when you do that, so they might clog up your diffuser. So that is, whoops, let me go back to reading view. That was the last slide of my presentation on chemistry and toxicology.
Thank you so much for watching. Look for more information on our website at redremedies.com. You can sign up for our newsletters and tap into the wealth of information that we have available. Talk to you soon.